Hello and welcome guys, my name is Steve and welcome to my channel where I share my engineering experience with you. So a little while ago I started a video series called Reminders-CLI and all of a sudden I just interrupted it, I just stopped it and it feels like it's dead. So today I decided to revive this video series. I decided to continue Reminders-CLI until we actually finish it. And today we're talking about the command line basics. What are the basics when it comes to writing command line applications? So we're gonna have lots of examples and lots of interesting things. Also, if you're new to this video series, make sure to check out the first two videos where we talk about the bare bones and how do we actually build the application from scratch. And without further ado guys, let's jump into the topic. So by this point you know that we want to create a command line application which is going to process a couple of commands and do something about it, do something with the input. So the commands we're talking about is create, edit, fetch, delete, and health. So if you're new to command line applications or to CLI in general, you may ask yourself, what does a command look like? The command consists of the binary or the executable, the command itself, and a couple of flags or arguments to that command. So in our case, the executable or the binary is bin client. The command itself is going to be, for example, the delete, and we have a couple of flags, for example, ID. So basically the ID is the flag or the parameter for the command delete. So that is an example of a command which we're going to run from the terminal. So whenever you build up a program and run the executable, or you just say go run main.go, there is something called os.Args for every time you run a program. So in case of Go, os.Args is nothing else but a slice which gets populated every time we run a program. It is a slice which has at least one element. So the first element of the slice is the binary or the executable which we try to run the program for. If you say go run main.go, the binary or the executable is going to be a temporary location. If you build your program and you run the program from the executable is going to be the path to that binary or that executable which you generated. And then os.Args can have other elements like the command, the arguments for that specific command, and all that stuff. So we mentioned previously command arguments or command flags. What exactly are those and how do they look like? Well, again, if you're new to command line applications or to CLI in general, a flag has a very simple structure. It basically can take one of these four forms: 2 dashes, the name of the flag, an equal, and the value of the flag, 1 dash, the equal sign, and again the value of the flag, 1 dash, a space, and just the value of the flag, or 2 dashes, a space, and the value of the flag. So this is how you identify a flag or a CLI command argument. Alright, now let's go ahead and jump into some examples regarding os.Args slice. So if you open up the project inside the text editor or inside the IDE, it's gonna have to look something like this. So I will assume you have watched the first two videos and you have a structure which just looks like this one. So you have the client, you have the CMD, the notifier, and the notifier is the only thing which pretty much works. Everything else is empty, and you have the server and you have the make file. So that's pretty much it, the structure you have to have by this point, by this time. So as I said before, I will assume that you have watched the first two videos and you are on the same page with us. So first of all, what I want you to do in this project is create a directory called examples, because we're going to have a couple of examples over here. We're going to play around besides the project. We're going to have some examples. So let's say examples, and inside examples, let's create another directory because we're going to have more examples. This one is going to be CLI Basics. We're going to have different examples when it comes to CLI Basics, and then let's create another directory here called os.Args, because right now we're playing with os.Arg examples, so let's have a dedicated directory for os.Args. And then inside os.Args, let's create a file called main, so let's say main.go, and let's give it a package main, say func main, and boom. Next, what I want you to do is go ahead and print out the os.Args slice, which we talked about earlier, which we said that it has the first argument, which is the executable or the binary. So all you have to do is say funct print line, and let's say os.Args, and there you have it. And let's import this func package. So when you run this program, and as I said before, you get the first argument, which is nothing else but the binary location or the executable location. And because we ran this example by using go run main.go, we actually generated a temporary location, and that temporary location, that temporary binary is going to be the first argument of this os.Args slice. Now let's go ahead and generate a binary by using go build command and have a look at what exactly is the first argument of this os.Args slice. So if you open up the terminal and say cd examples, and then CLI Basics, and then os.Args, as you can see, we're inside os.Args. So let's say go build, and the binary is going to get generated. So let's run this binary os.Args, and as you can see, the first argument of this os.Args slice is now the binary which we just generated by saying go build. So as we said before, the first argument is the binary or the executable, and the next following arguments of this os.Args slice are the commands or anything else which the commands need in order to run. So to prove that, let's go ahead and pass in more arguments when running this binary. So we're going to use the exact same binary which we just generated. So we're going to use os.Args, and let's say we pass in some argument 1, argument 2, argument 3. As you can see, os.Args now has more arguments. The first argument is, as usual, the binary or the executable, and then follows the next argument separated by space. So now that we know exactly that the first argument is a binary or the executable and the next arguments are the commands, we can make an assumption that the next argument after the binary is the command. So let's go ahead and start creating a command switch. So instead of printing this os.Args slice, we're going to add a small check. So let's say if, for example, len of os.Args is less than 2. So in case only one value is provided, which is the binary or the executable, it means we don't have any command provided, so we have to log out something, something like an error. So let's say font rent line, let's say no command provided, for example, and let's also say os.exit, and let's use a value like 2. So any value that is different than 0, it means it's going to exit with an error. So let's also import this font package so we don't have any errors. So let's also create the command switch, but before we do so, let's create a small variable cmd. It's going to be equal to os.Args index 1, which means if it passed this check, we at least have 2 values. So we're going to say command is going to equal the second value. Let's also add in the command switch. So let's say switch cmd, and we're going to fill out this later. We're going to come back to it later. So for now, I'm going to comment this switch out and run this program to actually make sure it does work, to actually make sure the if statement passes. So let's say go build again to regenerate the binary, and let's rerun the binary by saying os.Args. As you can see, it says no command provided, and inside my terminal, you can see this cross, this X, which means it ran the os.exit2 command. So if you run the same binary, and this time we're providing a couple of arguments, as you can see, nothing happens, which means it's a success case. Alright, let's go ahead and fill out this command switch we just commented out, and let's pass in some commands. Let's listen for some commands inside this command switch. So we're going to listen for 2 commands primarily. We're going to listen for the greet command, which is going to receive a flag called msg or message, and we're also going to fill in another command called help, which is basically going to print out some help message. And we're also going to add in a default case, which is basically going to print something out in case the user provided a wrong command or a command which we did not expect. So inside the text editor or the IDE, let's go ahead and uncomment this command switch, and let's add in a couple of cases. Let's say case greet, which is the first command, and let's also say case, and let's provide in help, and let's also say default, and in case the user provided a wrong command, let's for example say font rent, and let's print out something like unknown command, and let's provide in the command which the user provided, and let's also put out a new line, so command, and there you have it. Next, let's fill out the help case, and inside the help case, let's say font rent line, and let's say some help message. So inside the greet command, we're going to have a couple of things. First of all, we're going to have a default, a variable, which is going to default to some message in case we did not provide the msg flag, and then we're going to parse that msg flag and print something out. So let's go ahead and fill out the greet command. So as I said, we need a default, so let's say msg, and let's say reminders-CLI Basics. For example, this is going to be the default message. And now that we have the default message, let's go ahead and parse in these msg flags. So let's create a variable called f, which is going to be the flag. So f is going to be strings dot split, and we're going to split os.Args of index 2, because index 2 is going to be supposedly the flag. So we're going to have the command and then follows the flag after the command. It's going to be index 2, and we're going to split by the equal sign. So f is now a slice. Now let's go ahead and make sure that this f, the length of this f is actually equals to 2, which means we provided a value for this flag. So if length is equal to 2 and f of index 0 equals to msg, which means it's equals to this specific flag, then msg, which is this default message, is going to be equal to the value of this flag which was provided. And at the end, let's print out something like font print, for example. Let's say hello and welcome. And let's print out some string and a new line. So the string is going to be msg, which is either the default message or the flag which was provided by the user. So now that we have this command switch filled out, let's go ahead and generate the binary again and run this program and see what exactly gets printed. So let's say go build, override that binary with the existing binary. So as you can see, we have this binary. Let's say os.Args, and let's provide in some random command. If you provide in some random command, as you can see, it says unknown command. If you run this again and you provide in the help command, as you can see, it says some help message, which is basically the help command. And if you run this example again, and this time you provide write in the greet command, as you can see, we have an error. We have an error because we did not check for the length before we did the split over here. So let's go ahead and add in a small check to fix this error. So let's wrap this one inside a small if, and let's say if len of os.Args is greater than 2, we're going to run this one. So if len of os.Args is greater than 2, it means we have at least 2 elements, and we can run this code safely without having any errors. Otherwise, we're just going to print the default message. So in order to run this example again, let's first of all say go build to regenerate the binary, and now let's run this example again. And when you run this example again, as you can see, the default message prints out. Now, if you pass in the MSG flag, as you can see, things are going to get printed a little bit different. So let's say yo. And if you pass in, it's going to say hello and welcome yo. So basically, this is how you create a command switch using the os.Args slice. Alright, so writing command line application using the os.Args slice is not the best approach and is not the best way to write command line application. And as you could see, and in my humble opinion, actually that looks quite messy, that looks quite ugly and unmanageable. So the question is, can we do this better? Of course we can do this better. That's why the next thing we're talking about are flag sets, how we can use flag sets in order to improve our code. So basically we will rewrite the previous example to make use of flag sets, and you will see how much cleaner and how much manageable and better the code gets. But first of all, you may ask yourself, what exactly is a flag set? So a flag set in Go is nothing else but a command. Basically you just create a flag set, and the flag set wraps every operation when it comes to parsing commands, command flags, and all that stuff. So in order to create a flag set, in the standard library, the Go team has created a package which is called flag. So that flag package has a function called new flag set, and that new flag set function gives you back a pointer to the flag set, which basically unlocks a lot of operation when it comes to parsing commands, parsing command flags, and all that stuff. And as you could see, when parsing in flags, it gets pretty messy and it gets pretty complicated. And imagine you have a lot of flags, it gets pretty messy and unmanageable. That's why the Go team has done pretty much everything for you. So if you want to parse like strings, ints, you don't need to do any validation, you don't need to split things around like we did in the previous example, and you will see how simple it is to use flag sets. As soon as you have a pointer to that flag set type, you have a lot of methods available to working with different types like string, like int64, and all that stuff. So it's pretty much up to you how you use these functions, but without further ado, let's go ahead and jump into an example. Let's rewrite the previous example to using flag sets. What I want you to do is open up the IDE or the text editor, and inside examples, CLI Basics, let's copy os.Args. So let's make a copy of it, let's paste it and name it flag set, for example, just to not waste a lot of time rewriting all this code from scratch. And let's actually keep the help on the default. Let's remove the greet, or let's actually keep the greet case. So let's keep the example this way and rewrite the code so we use flag sets. So all you have to do is create a command or a flag set so that you get a pointer to the flag set. So let's say greet command, for example, equals to flag.new flag set, and we're going to give it a name, for example, greet. And then we need a function which is going to handle those errors in case we have some errors when parsing this command or these flags. And in the previous example, we had os.Exit2, so there is a similar function for that. So let's say flag exit on error, and if you open up exit on error, as you could see, it says call os.Exit2. So now that we have a pointer to flag set, let's go ahead and create a flag for this command. So we know that we need a flag called MSG. So let's say MSG flag equals to, let's say, greet cmd.string, because that's going to be a string. And as you can see, the first argument is the name. So the name is going to be MSG, and then we have the value. The value is going to be like the default value, let's say CLI Basics, reminders-cli, for example. And the third argument, as you can see, is the usage or the message which is going to get printed when we try to run help flag on this command. So let's say this is going to be the message for greet command. Now that we have the command and the flag on this command declared, all you have to do is call the parse method on this command. So let's say greet cmd.parse, and parse is going to require us to give it a slice of arguments. So we're going to say os.Args, and we're going to select everything from index 2 upwards. And as you can see, this parse method actually returns an error back. So let's go ahead and capture this error inside the variable, and let's say if error is not nil. So in case we get an error, let's just say log.fatal, and let's say error.error. So we're going to print an error back to the terminal. And after that, let's print the exact same message at the end by saying font.print, and let's print something like hello and welcome, and let's print out the message, which is going to be because this is a pointer, let's say value, and let's say MSG flag. So we're using this star because this is a pointer. As you can see here, the string method returns a pointer back. That's why we need to use the star or the value of this pointer. So again, if you open up the terminal and you cd into examples, CLI Basic, and then after that you cd into flag set, as you can see, you have this main.go. So let's say go build. After you say go build, we have the binary. Now let's run flag.set. If you run flag.set, it says no command provided because this is the default case. If you run flag.set and you provide in the help, it's gonna say some help message. If you run in flag.set and you say, for example, greet, and you don't provide anything, it's gonna say hello and welcome CLI Basics, which is basically the default value for this flag. And if you of course say --msg equals to, or you could even say space, because this is a full flag definition as I showed you before. So msg space, let's say yo, it's gonna print yo because that is the flag value, and that is what's gonna get printed because we actually received the value and we're not using the default. And also one more quick tip, when you're using flag.set, it's gonna automatically add the help flag on a specific command. Let's call again flag.set, and if you type in greet and you say --help, as you can see, it's gonna display a beautiful info about how to use this command. And that is what we don't get by using os.Args, and that is what we do get when we use flag.sets. So this is a simple example of how to convert a program from using os.Args to using flag.sets, which is a better way, which is a more manageable and more elegant way, I would say. So the good thing about flag.set types is the fact that we're not only limited to using basic types or primitive types. We could also create custom types and use custom types instead. So all you have to do after you create a custom type is to implement the flag.Value interface from the flag package. So basically any type that implements the string method, which returns a string, and implements the set method, which receives a string and returns an error, that is a flag.Value. So the advantage of implementing the flag.Value interface in your custom type is the fact that you can pass in any value inside the command line and then take in those values and convert them into your custom type without worrying about any conversion inside the code. So without further ado, guys, let me show you an example to show you what I mean by that. So what I want you to do is open up your text editor or the IDE, and inside example CLI Basics, let's create in another directory called flag.Value. So let's say directory flag.Value, and let's create in another file called main.go. So let's say go file main.go, and the package is going to be main func main, and there you have it. And now let's go ahead and create a custom type called IDs or IDs flag, which is basically going to parse different IDs from the command line, and then in the end it's going to convert those IDs into a slice of string. How cool is that? So let's go ahead and implement that. So let's go ahead and create a type called IDs flag. So let's say type IDs flag, and that's going to be a slice of string. And now that we have created this custom type, let's go ahead and implement the flag.Value interface. So the first method we have to implement is the string method. So let's say func. We're going to have the receiver here. So let's say IDs. It's going to be IDs flag, and then we're going to have string. It's going to return a string. So let's return an empty string for now. Return empty string, and then let's implement the next method, which is set. So let's say func, the same receiver, IDs flag, and let's say set. And set is going to receive an ID which we're going to pass from the command line. So let's say ID is going to be string, and let's say it's going to return an error because that is the signature of set. So let's return nil for now. So let's say return nil. So as you can see, we successfully implemented the flag.Value interface. So inside the main function, let's go ahead and create a variable and bind that variable to a specific flag. So let's say var, and IDs is going to be IDs flag, and then let's say flag.var. We have such a method called var, and var accepts a couple of arguments. As you can see, var accepts the value first, so the value is the flag.Value interface, or basically this custom type which implements the interface already. So let's pass in the address of IDs, and let's also pass in, as you can see, the name. So the name is going to be ID, so we're going to ask for ID individually and then append that ID to the ID slice or to the IDs flag slice. So ID, and then we have the usage or the description. So let's say the ID to be appended to the list. And then as usual, we have to call the parse method. So let's say flag.parse, and as you can see, we successfully parsed the flags. And then at the end, let's just print the result of this IDs variable. So let's say font_println, and let's print in IDs. So let's go and open up the terminal and cd into examples, and then CLI Basics, and then let's cd into flag.Value, which we created, and then we have main.go. So let's go ahead and say go build, and as you can see, we successfully generated the binary flag.Value. So let's run flag.Value. As you can see, apparently nothing prints, but actually an empty array prints. So let's say flag.Value, and this time pass in ID equals 1. Let's say ID equals 3, and let's say ID equals, for example, 18, right? As you can see, nothing happens because we have empty implementations. So let's go ahead and fill up those implementations. So inside the string method, let's go ahead and print a comma-separated list of IDs. So let's say strings, and let's say join let's say IDs, and let's join them by a comma. So that is pretty much it on the string method. And now let's fill up the set method. Inside the set method, we still want to return nil because we don't want to return an error. And then after that, let's slightly adjust the receiver so that we actually populate the change when we try to append to this slice. So inside of this receiver, let's add in a star, which is going to make it a pointer receiver. And then let's say value of IDs equals to append, and it's going to be again value of IDs, and it's going to be the ID. It's going to be the ID. So that is all you have to do in order to fill in this implementation. So inside the terminal, let's say go build again to regenerate the binary, and now let's rerun that example again. And when you rerun this example again, as you can see, we have a slice of values and we don't have to do any conversions inside the code. That is done automatically for us by using this custom type and implementing this flag.Value interface. Now, as you can see from this example, we're not only limited to slices, we can create any type. So let's go ahead and create a type called person, which is going to be a struct. So I'm going to go ahead and say type person, and person is going to be a struct. And it's going to have a couple of fields. So let's say name is going to be a string, and it's also going to have a born field, which is going to be the time which was born at. So let's say born is going to be time. And now let's actually implement the flag.Value interface. So let's say func, and let's add in the receiver. So let's say p person, and let's say string is going to return a string, and let's return, for example, let's return font as printf, and let's say, for example, my name is, let's print in the string, and I am, let's print in another string. So it's gonna be p.name, and it's gonna be p.born.string. So there we have it. We successfully implemented the string method. Now let's implement the set method. So let's also say func, and we're gonna pass in p person. However, this time the person is gonna be a pointer receiver in order to propagate the changes. So let's add in the star real quick, and let's say set. Set is gonna receive the name. So we're going to pass in name from the command line and then convert it to a person type. So name is going to be a string, and it's going to return an error. So we're still going to return nil because we don't want any errors. So return nil. And this time we're going to say p.name equals to the name which we receive from the command line. And p.born is going to equal to time.now. So there's a function called time.now, which is going to get the current time. Now let's go ahead and create another variable inside main and run this program. So inside main, I'm just going to duplicate this line, and I'm going to duplicate this one. I'm going to say p is equals to person type, and we're going to pass in p here, and we're going to look for a flag called name, and let's add in a description. Let's say the name of the person. Let's also print out p to see what exactly gets filled inside this person. And now let's go ahead and regenerate the binary and run this program to see what exactly gets printed. You run go build, you regenerated the binary, and now let's say flag.Value, and let's use, for example, the same example as previously, and this time let's say name equals, for example, John. And as you can see, something like this gets printed. It says my name is John, and it prints this timestamp. So that's how you use custom types. You implement the flag.Value interface, and you actually parse in raw values, you parse in strings from the command line, and you convert them to your custom types, you convert them to your own custom types without needing to put in any effort. That is done automatically for you by implementing the flag.Value interface. So that was pretty much it on this video, guys, and that was pretty much it on this video series on reminders CLI. So if you like this video, make sure to put a thumbs up. If you didn't like this video, smash it, and subscribe if you aren't already. And without further ado, guys, make sure to check out the resources section of this video in the video description below. And yeah, stay tuned, and I'll see you guys in the next video. Peace!